Lesson: Sentiment Analysis for Threat Intelligence Gathering. Sentiment analysis, a subset of natural language processing, plays a pivotal role in threat intelligence gathering within the cybersecurity domain. The ability to analyze and interpret sentiments from diverse textual data sources empowers security professionals to detect potential threats, gauge public sentiment, and preemptively address vulnerabilities. This lesson explores actionable insights, practical tools, frameworks, and step-by-step applications to enhance proficiency in sentiment analysis for threat intelligence, providing a roadmap for security operations. Sentiment analysis involves the systematic identification and classification of opinions expressed in text, typically categorizing them as positive, negative, or neutral. In the context of threat intelligence, this technique is employed to gauge the sentiment surrounding particular topics, individuals, or organizations that might indicate a potential threat. For example, analyzing social media chatter can reveal negative sentiments toward an organization that may signal an impending cyber attack or a coordinated disinformation campaign. Leveraging sentiment analysis in threat intelligence requires a robust understanding of NLP tools and frameworks. One widely used framework is the Natural Language Toolkit, which offers comprehensive libraries for text processing and sentiment analysis. NLTK provides tools for tokenization, stop word removal, and stemming, which are essential pre-processing steps in sentiment analysis. By employing NLTK, security analysts can pre-process large datasets, making them ready for sentiment classification. Another powerful tool is Vader, a lexicon and rule-based sentiment analysis tool specifically designed for social media text. Vader is adept at analyzing the sentiment of text with emoticons, slang, and informal language, which is often the case in social media platforms. Its ease of use and high accuracy make Vader an ideal choice for rapid sentiment analysis in real-world threat intelligence scenarios. Sentiment analysis can be further enhanced by integrating machine learning algorithms to improve accuracy and predictive capabilities. Frameworks such as scikit-learn offer an array of machine learning models that can be trained to identify complex sentiment patterns in textual data. By training models on historical data, security professionals can predict future sentiment trends and identify potential threats before they materialize. In practical applications, sentiment analysis has been invaluable in detecting cyber threats associated with hacktivism. For instance, during Operation Payback, a series of coordinated attacks by the hacktivist group Anonymous, negative sentiments on platforms like Twitter and Reddit were precursors to DDoS attacks on targeted organizations. By analyzing these sentiments, security teams could have anticipated and mitigated the impact of such attacks. Moreover, sentiment analysis can aid in identifying insider threats by monitoring employee communications for negative sentiment trends. By analyzing emails, chat logs, or internal forums, organizations can detect disgruntled employees who may pose a security risk. Implementing sentiment analysis tools such as IBM Watson's Natural Language Understanding allows for real-time monitoring and alerts, enabling organizations to respond proactively to potential insider threats. To effectively implement sentiment analysis in threat intelligence, security professionals should follow a structured approach. The first step is data collection, where relevant sources such as social media, forums, and news articles are identified and gathered. Utilizing web scraping tools like Beautiful Soup or APIs from social media platforms can facilitate efficient data collection. Once the data is collected, pre-processing is crucial to clean and prepare the text for analysis. This involves removing noise, tokenizing text, and normalizing language to ensure accurate sentiment classification. Post-pre-processing, the sentiment analysis is conducted using either lexicon-based methods like Vader or machine learning models trained with scikit-learn. The choice of method depends on the specific requirements and characteristics of the dataset. For instance, lexicon-based methods are suitable for quick sentiment assessments, while machine learning models offer deeper insights and trend predictions. Finally, the insights gained from sentiment analysis should be integrated into the broader threat intelligence framework. This involves correlating sentiment data with other intelligence sources such as network logs, threat feeds, and historical attack data. By synthesizing these insights, organizations can develop a comprehensive understanding of the threat landscape and implement targeted security measures. The effectiveness of sentiment analysis in threat intelligence is underscored by its application in various case studies. In 2020, sentiment analysis played a crucial role in identifying disinformation campaigns related to COVID-19. By analyzing social media sentiment, researchers uncovered coordinated efforts to spread misinformation, enabling authorities to counteract false narratives and protect public health. Statistics further highlight the growing importance of sentiment analysis in cybersecurity. According to a report by Markets and Markets, the global sentiment analysis market is projected to grow from $3.2 billion in 2020 to $6.3 billion by 2025, driven by the increasing adoption of AI and machine learning technologies in threat detection and response. In conclusion, sentiment analysis is a vital component of threat intelligence gathering, offering actionable insights that enhance security operations. By leveraging advanced NLP tools and frameworks, security professionals can effectively analyze sentiment data, anticipate potential threats, and implement proactive measures. The integration of sentiment analysis into a comprehensive threat intelligence strategy not only strengthens an organization's security posture, but also ensures a timely and informed response to emerging threats. Through continuous learning and adaptation of sentiment analysis techniques, security professionals can stay ahead in an ever-evolving cyber threat landscape.